Alright, section 4.5 is on quadratic equations. We've been working with quadratic functions for a little while now, but today we're going to start solving quadratic equations, which means we're going to be finding out what x is equal to, and we're going to do this in a variety of methods. What we're going to do today is based on factoring. However, we're also going to look at some features in your graphing calculator that will help. And there will be times you will still have to show all of your work, but you are more than welcome to verify your work and your answers in the calculator. So where we're going to start at is practice problem number 1 on page 226 from your book. It says, what are the solutions of x squared minus 5x plus 6 equals 0? So the very first thing you're going to do is you are going to factor the left-hand side. Okay, so I want to take this and factor it. It is a trinomial with a equal to 1. So I'm just going to start with an x in each parenthesis because x times x gives me x squared. To get a positive 6, I either need 2 positives or 2 negatives. This tells me I need 2 negatives. Numbers that will multiply to be 6 and add to be 5 are a negative 3 and a negative 2. Now that is still equal to 0. So now let me explain to you the next step, and then we'll write it over here in our box. Okay? If this entire parenthesis were equal to 0, and I multiplied 0 times this parenthesis, I'm going to get 0. So I want to know what will make that first parenthesis equal 0. Also, if this parenthesis were equal to 0, and I multiplied this 0 times the other parenthesis, I'm still going to get 0. So I also need to know what makes this parenthesis equal to 0. So here's what step 2 is. Okay, step 2, you're going to set each factor equal to 0. So now step 3, we're going to solve each of those equations. So for this one, I'm going to add 3 to both sides, and I get x equals 3. For this one, I'm going to add 2 to both sides, and x equals 2. So x equals 3 and 2. That is your solution. You have 2 of them. Here's the thing, because this is an x squared, most of the time you're going to have 2 solutions. Sometimes you will only have 1. Occasionally you won't have any solutions, but you could have up to 2. So now we need to talk about some terminology, and then we're going to come back and talk about what these solutions tell us. Okay? So now, some vocabulary that you will need to be familiar with are these words: roots, solutions, zeros, and x-intercept. All of these mean the same thing. Okay? I will use those words interchangeably. So now, since we know that these can be used interchangeably, let's go back to our first problem up here. These were my solutions. Well, guess what? They're also the roots, the zeros, and the x-intercept. Okay, x-intercept I want to go ahead and talk about and look at on your calculator. So I'm going to slide this over so I can see the problem while I grab my calculator. And I'm going to type in that equation at the top. But instead of 0, I'm going to make that a y. So I want to type in y equals x squared minus 5x plus 6. Alright, so there I've got it typed in. Let me get my big version of the calculator here. So now you can see it, and let's graph it. And as it graphs, I want you to pay attention to where my graph touches the x-axis. Okay, if you're looking at it on a small screen, it's a little hard to see. The big screen is a little bit better. And you can see that it touches the x-axis right here at +2 and +3. There's a way to make that view a little bit better on these calculators. So I want to walk you through how to do that. When you come back to class next time, you need to try it on your calculator and let me know if you need help, and we can go back through it together. Okay, you're going to press zoom, but we're going to now choose option 1. We're going to zoom with a box. So you can see that my cursor is now blinking at 0, 0. What I want to do is I'm going to move my cursor down. And I'm going to move it over just, let's go back. I'll go back on top of that y-axis. Okay, I want to go down so that I am below the vertex. Now I'm going to press enter. And I'm going to go to the right until I get to the other side of the vertex. And now press up. This is going to open a box. I want to make sure I go across that x-axis. So inside my box, I need to have the vertex of my parabola. I need to be able to see the x-axis. And if we can see the origin, or at least know that it's going to be on the left-hand side of my screen, that's even better. You know, that works well. So now that we've got all of that in our box, let's press enter. And what happened was the picture inside my box now fills the entire screen. So you can see a little bit better that my graph touches the x-axis at 2 and 3. Okay, and remember, you can always go back to the regular window, the standard window, by doing zoom 6. All right. So that's why they tell us that these solutions we found here are also the x-intercepts. Now, why do they call it the zeros? Well, because if these are my x-intercepts, as ordered pairs, they are 3, 0, and 2, 0. So these are the numbers I get when y is equal to 0. So we've already talked about solutions, zeros, and x-intercept. The roots, we're going to hold off on talking about that in detail until we get to sections 4.6 and 4.7. Okay? So now let's go ahead and go down here to problem number 2. What are the solutions of 5x squared plus 30x plus 14 equals 2 minus 2x? Now, this problem looks a little bit different than the last problem because the last problem had equal to 0 over here. Well, guess what? That's my first step here. I need to move everything to one side so it's equal to 0. So move all terms to one side so it equals 0. All right, so I'm going to recopy this here. Now I'm going to subtract this 2 from both sides, so it'll be gone from here. At the same time, I'm also going to add this 2x to both sides. So it cancels here. And that will give me 5x squared plus 32x plus 12 equals 0. And now we're going to work it just like we did the last one. So we're going to factor the left. And this time we're going to have to work a little bit harder at factoring, because this is a trinomial, a is not equal to 1, and I don't have a greatest common factor. So we're going to have to factor using bottoms up. So let's take my 5, multiply it by the 12, x squared plus 32x plus 60 equals 0. Now I can use my two parentheses. X times x will give me x squared. To get a positive 60, I either need two positives or two negatives. This tells me I need two positives. And then I need numbers that will multiply to be 60 and add to be 32. If you're not sure what those are, you can make a list out here. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. After that, they start to repeat. The pair that will add to be 32 is this pair. So I'm going to have x plus 2 and x plus 30. But remember the 5 you multiplied by at the beginning. Come back and divide by it. In the first parenthesis, that does not reduce. It does not give me a whole number, so I'm going to move the bottom up front. In the second parenthesis, 30 divided by 5 is 6. That gives me a whole number, so you just go ahead and divide it, and there you go. Okay, so step 2, the factoring is done. The next thing we do is we're going to set each factor equal to 0. So my 5x plus 2 equals 0. X plus 6 equals 0. And now we solve both of those. So for the 5x plus 2, I'm going to subtract my 2 from both sides. Gives me 5x equals negative 2. Divide both sides by 5, and x equals negative 2/5. For the other one, subtract your 6 from both sides, so subtract here and here, gives me x equals negative 6. So your solutions are x equals negative 2/5 and negative 6. Alright, so you can check this in your graphing calculator. So let me slide this over so I can get it all up here. So let's clear out that old equation. And the one I want to type in here is after I have it set equal to 0. Okay? Because since this is a solution, which is also an x-intercept, y is 0. That's why I can change this 0 into a y. Okay? So y equals 5x squared plus 32x plus 12, and graph it. So now I can't see the whole parabola here, but I can see where it touches the x-axis. It touches somewhere between 0 and negative 1. Well, negative 2/5 is between 0 and negative 1. Then let's find out what this one is. So there's -1, -2, -3, -4, -5, -6. So that confirms what we found when we worked it by hand. This is an example of when looking at the graph is not necessarily an effective way of finding the solutions. Yeah, you could get one of them from the graph real easily, but I seriously doubt many of you would look at that and say, oh, that's -2/5. Okay, so you're going to have a variety of methods to do this. All right, so now let's look at the next page on my notes, and this is where we're going to come back to the calculator and look at another feature in it. Okay, so here, problem number 1. This takes us back to the same problem we did a few minutes ago that we already graphed in the calculator and we looked at the graph. However, we can also figure out what the solutions are from the table. So let's go back to my calculator. Slide this over so I've got room. Let's go back and type in x squared minus 5x plus 6 and graph it. Right, we already talked about how you can look at the graph and see where it touches the x-axis. We even talked about how to make this bigger, how you could zoom in and zoom in exactly where you wanted to by doing a zoom box so that you can see better that it touches at 2 and at 3. So let's add this to our notes here. Okay, on the graph we want to look and see where the graph crosses the x-axis. Okay, let me move this out of the way just a minute. All right, so the next thing I want to look at is the table. All right, so I'm going to get my calculator back up here. So there's that part, and there's that one. Let's take a look at the table. And remember, we talked about on the previous page of notes that, you know, this is where the graph touches the x-axis. And if they are x-intercepts, the ordered pairs look like this. If it is an x-intercept, my y is always 0. So, in my graphing calculator on the table, I want to find where y is 0. If you can find that, you know, you have 0 in the y column, the x that goes with that, that is your solution. All right, so when you're looking at the table, you want to find x values that have y equal to 0. That's what you're looking for in the table. So here with one problem, we already have 3 different ways of finding the solutions. You can factor it. And yes, I will make you do some of these by factoring. You can look at the graph, and most likely on the test, I will give you a picture of a graph with no equation attached and just ask you what the solution is. You can also find the solutions from a table. And I will also give you a picture of a table with no equation attached and ask you to look at that table and tell me the solutions. And remember, that's where you're just looking for zeros in the y column, and you choose the x values that go with it. All right, so problem 2, same one we did on the other page. We did this by factoring. We even looked at the graph. But remember, when I looked at that graph, I had to type it in once I had all terms on the same side. Oops, that's 32 and 12. Let's fix that. (32x plus 12 equals 0). Remember, all you're doing is changing this 0 into a y and type it in. So let's grab my calculator and put it back up here. We'll look at this graph one more time, but we're also going to look at the table. So I want to type in y equals 5x squared plus 32x plus 12. Okay. We already talked about looking at the graph and that you can see where it touches the x-axis. The negative 2/5 is a little hard to get from the graph. So let's take a look at the table and see if that's any better. Well, I know from the graph that my solutions are negative x values. So I want to look at negative x values in my table. So you can see right here where x is -6, y is 0. So you can confirm that in your table. But I don't have a negative 2/5 in my table. So how in the world am I supposed to get that one? Well, I know from looking at the graph that it touches the x-axis between 0 and -1. So I'm going to take my table and I want to look at it a little bit more closely between 0 and -1. So how do we do that? We've got to change our table setup. So second table set, I want it to start at -1, and I don't want to count by whole numbers this time. I want to count by decimals. Let's count by 0.1 and go back to our table. So you can see that I'm at -1, -0.9, -0.8. So my x values are counting by 0.1, and now I can see a 0 in the y column. So when I see that other 0, x is -0.4. Well, I already had the -6 from the table, and now looking at the table, I'm getting a -0.4. Well, guess what? -0.4 is the same as -2/5. So that will let me confirm what I did when I worked it by hand. All right, so now I've got one more problem, and what I want you to do is I want you to pause the video. I want you to solve this one by hand, and then we're going to take a look at the graph and the table here together. But when you come back to class tomorrow, I need you to take out your notes, grab a graphing calculator, and try these 3 problems. See if you can figure out how to use the calculator to look at the graph, how to look at the table, to change the values in the table to find your solutions that way as well. All right, so go ahead and pause the video. I will work it out down here, go through the calculator stuff. When you're done working it, come back and check. Alright, so first thing I'm going to do is move everything to the same side. So I'm going to move my 15 over here. When I do, it changes signs because technically what I did was subtracted 15 from both sides. Now I have to do bottoms up. So I'm going to multiply the 2 times the -15. Factor that. So I'm going to need one positive and one negative. I can use a positive 10 and a negative 3 because those multiply to be negative 30. They also add to be 7. I've got to remember to come back and divide by 2 in both parentheses. The first one, I get x plus 5. The second one is 2x minus 3. So now, set each of those equal to 0. So x equals negative 5. And x equals 3 over 2. Alright, so I've gone back up here and put my answers up here next to the problem. And now when I use my calculator, this is the step I want to type in. And remember, we're going to change that 0 into a y. So y equals 2x squared plus 7x minus 15. Oh, I need to clear all that out. Let's try that again. Alright, now that we've got it typed in correctly, let's go ahead and graph it and see if we can verify the negative 5 and the 3 halves. So here's my big screen again. Well, there's negative 1, negative 2, negative 3, negative 4, negative 5. I can see that. And then 3 halves is 1 1/2. So is that answer reasonable based on our graph? Yeah, it looks pretty good because my graph touches somewhere between 1 and 2, and it looked pretty close to the middle. So we've looked at it with the graph. Now let's take a look at the table. So now, my table is counting by decimals. So I'm going to have to scroll a long way to get to negative 5. If I go look at 3 halves, which is 1 1/2, I don't have to scroll quite as far. I could always reset my table, but this one it's not too bad to scroll. So you can see there at the bottom of my table the way it is now, when x is 1.5, y is 0. So that is a solution. 1.5 is the same thing as 3 halves. But now I want to go up and take a look at my table when x is negative 5. So I'm going to change my table setup. So here's where we're going to try something that I've never done before. I don't even know that the calculators in here do it, but some of you have your own graphing calculators, and they are a more updated version. So they have this that's at the top of my table that says press plus for delta table, which is the change in the table. So let's press it and see what happens. If that doesn't work, we'll go back to our table setup. Okay. If I press the triangle table, that's just going to let me tell it to count by decimals, or I can count by whole numbers. So let's go back to counting by whole numbers. Hit enter. And so now, well, it's not counting by whole numbers because it's counting by ones, but I was on a decimal value. So it's going to add 1 or subtract 1 from that decimal value every time. So let's go to our table setup and see if we can do this a little bit more easily. I'm going to have my table start at negative 5 because that's the value I want to look at. And since we're going to start at negative 5, I can count by whatever I want to. So I'm just going to leave it set at 1. Press graph, oh, not graph, table. And you can see that when x is negative 5, y is 0. Right? So that is it for section 4.5. We're going to do a lot of practice with this in class. You'll be able to use the calculator to verify your answers, but you will have to solve some of these by just factoring. All right, so that's it for 4-5.